I'm solving trigonometry. So what we're going to do this lesson is solve some problems using trigonometry. All the rules we learned so far. And the first step is knowing which one to use first. So if you have a right triangle, then probably use SOHCAHTOA. Right? Then we can use all the SOHCAHTOA stuff we want. And Pythagorean theorem. Right, where C is the hypotenuse. If you have a non-right triangle, that's when the law of sines, the law of cosines comes in. Right, so right triangle, SOHCAHTOA, a squared plus b squared equals c squared, Pythagorean theorem. Non-right triangle, then you have to use law of sines or law of cosines. I generally say this: if you have a pair, then it's law of sines. So that means you have a side and its angle. So I have like this angle and this side. And if you have no pair, it's law of cosines. Now those examples are here. 3 sides, you have 2 sides and a acute angle. So that's pretty much it. Let's do some examples, or a couple of examples. The angles of elevation to the top of a mountain are measured from 2 beacons A and B. So beacon A, beacon B. The measurements are shown on the diagram. The beacons are 1,473 meters apart. How high is the mountain? So we're saying this right here is 1,473. And we want to figure out what this is. So we gotta, so like it's a right triangle here. So I could use like SOHCAHTOA and stuff like that. But I don't have any other values to go with. Now I'm probably going to use this triangle to solve some things. So this is 1473. If I wanted to use all cosines, I would need either this side right here, which I don't have, or I need all the sides. If I'm going to use all the sides, I do have this angle. So I could use this side. Here's the key though. Right here is the key to this problem. This right there. That is it's a straight line, so that is 180. So let me draw this triangle bigger. Let me repurpose this triangle. Then we have something like this. Right, so this is A, which is 29.7. This is 41.2, and this is a right angle. I'm looking for this. The key to this problem is right here, like I said earlier. This is 180. This is a straight line. So if I do 180 minus 41.2, I get this angle right here. You might, oh, by the way, this also equals from here to here, specifically 1,473. And that's going to help me get this, find this angle here is going to help unlock this whole problem. So first let's find out this missing angle. So bring up my calculator, make sure I'm in degrees. So 180 minus 41.2, and I get 138.8. Now again, that's only this portion right here. So how does it help me solve everything? Well, now I can figure out what this angle is. And that'll give me a pair of sides, which I use all sines on. So I'm going to do 180 minus these two angles to give me this corner angle right here. So 180 minus the answer I got, minus 29.7, barely read my own writing, and I get 11.5. It's a tiny angle. So 11.5 is right there. And now I have a pair of sides. And like, well, how's that gonna help me? Well, if I use this one and this one, right, law of sines. So I'm gonna do 1473 over sine of 11.5 equals, let's find this guy first. With this angle, right? So that help me, and then now I have something on this triangle next to it. And once I get that, I could do SOHCAHTOA. So we're gonna do, let's call this C, I guess. C over sine of 29.7. Now again, if I'm solving for C, I don't have to cross multiply. C is right there. Just multiply both sides by sine of 29.7, which is just a value in our calculator. So sine of 29.7, sine of 29.7. These cancel out. You get C equals whatever that is. Using my calculator. 1473 divided by sine 11.5. Then I'm going to times that by a sine of 29.7. And I get 3660.62 approximately. So that's how long this guy is. Just happen to make videos at work. Anyway, now I have a right triangle. So if I just look at that right triangle by itself, this is 41.2. So much noise. This is 3660.62. I'm looking for this. Label my sides. Opposite. Hypotenuse. So this is my favorite trig function, sine. Sine of 41.2 equals x over 3660.62. And I'm going to multiply both sides by this. And get my answer. So let's do my calculator. So I'm going to get this guy and then times it by sine of 41.2 to get the height of the mountain. So there we go. 2411.213. Let's go 2411 equals the height in what meters? Something like that. Height of the mountain. So there we go. Alright, in this case I had to use the 180 rule. Like if you have a straight line, it's 180. And then this law of sines, got this side. It was a right triangle. How lucky. Now I can just use SOHCAHTOA. So let's do one more. A bearing problem. A ship sails from a harbor on a bearing of 084 for 340 kilometers until it reaches point P. That's what you see right here in the top part. So 84 degrees, right? Stop there. Go 340 kilometers to point P. And then we draw another bearing, another like compass part right there. It then sails at a bearing of 210. So from there, it turned to 210 for 160 kilometers until it reaches point Q. So that's sort of right here right now. Calculate the distance between Q and the harbor. So that would be this value. So in this case, I'm probably going to use law of sines, law of cosine. So this is 340, this is 160. I have these two sides. I can't use Pythagorean because it's not a right triangle. At least I don't think so. I could figure it out in a second. But what I could do is like if I figure out what this angle is, I could do law of cosines. Or if I figure out what this angle is, I could do law of sines. If I figure out this angle is, I could do law of sines. Alright, so we have that. So first let's try to figure out what this angle is right here. So these two are always parallel, which makes this angle right here 180 minus 84, right? If you have parallel sides, same side as 180, so 180 minus 84 gets me, what's that, 96 degrees right there? And with that I could figure out what this angle is right here, because this is a full circle. I go 360 minus this minus that. So if I want to figure out what that is, a little hard to see. I want to figure out what this is. That is just going to be 360 minus 210 minus 96, which is about 54 degrees. So right here would be 54 degrees. And now I can actually solve this. Now it's not law of sines because I don't have this side right here, but it is law of cosines. I do have two sides and an included angle. So I could do law of cosines. So the law of cosines in the information sheet is c squared equals a squared plus b squared minus 2ab cosine of c. Now a couple of things. There's also one for angles, but we have an angle. We're trying to look for a side, so we're going to use this one. And then again, notice how it's PQH, but my law of cosines has like ABC. The general idea is whatever you're looking for is your C. So to me right now, this is my C, which makes this angle, big angle C. And then A and B don't really matter. So C squared, or in this case, I guess X squared. I made that a big C. Probably shouldn't do that. So we're just going to say, I'll say X squared equals 340 squared plus 160 squared minus 2 times 340 times 160, it's a little hard to see, times cosine of my angle, which is 54. Notice there's no variables at all. I'm just going to type that all into my calc and get an answer. So let's move back my calculator. So we're going to do 340 squared. I'm going to turn it on, I guess. 340 squared plus 160 squared minus 2 times 340 times 160 times 340 times cosine of 654. So I get that, and that's what x squared equals 77,248.96 la la la. 6 square root of both sides. And I get x is approximately 277.936. We're doing 3 6 figs, 278. So we've got about 278 kilometers. There we go. Probably helps if I move my calculator so you can see it. Okay, next part. On what bearing must a ship sail to return directly to harbor from Q? So we're right here, and we want to go right back to Q. So a couple things. Let me erase this. I know what that is now. So we could write, in this case I need it, write 278. And since that's an answer, I could use that. I don't have to like use the answer from my calculator. I could actually use that now. Since that was an answer for A, I could use that for the rest. But anyway, I want to find out what bearing this is. So go from here all the way to there. So the bearing, again, you start always north. So we're going from here all the way to here is what we're looking for. That's why the best circle. From here all the way to here. That's what we're looking for. So the easiest way to do that, I'm not sure what the easiest way to do that would be. So this is 180. I could figure out what this is. I'm going to do a couple of things here. I definitely want to figure out what this angle is right there. But that won't be the end of it, because I still need to figure out what this tiny angle is right here, which is a separate thing. Okay, so let's figure out what that angle is. First, I could do law of sine to do that. So I could do this. I could do, let's see. To find out all of that, I'm going to do, this angle goes with 340. So 340 over sine of Q equals 54 and 278. So 278 over sine of 54. This one I'll probably cross multiply. So I get sine of Q times 278 equals 340 times sine of 54 and divided by 278. So these cancel out. So let's put that on my calculator. It sounded a little funny. And then divide it by 278. So 0.98 blah blah. Now that's what sine equals. So sine of Q equals 0.9894 blah blah blah. Now I'm gonna do inverse sine to get rid of the sine part. So second inverse, that answer. Let's use that answer there, don't round it. I get 81.6. I would say in this case, I'm going to use 81.7. I was doing 3 6 figs. So there we go. So like that. Now, that's not my final answer. So that's all of this. So all of that's 81.7. Now, again, that's not the bearing, because the bearing is from the north all the way there, and this part has part of the north on it. So I got to subtract off this little angle there. So let's declutter this a bit. Let's only look at this portion. So again, I got to figure out this. What I'm trying to find out is what this is. And the reason I'm trying to figure out that is because I could just do 360 minus that, and it gets me the bearing I need to get to H. So I'm trying to find out what that part is. I know the whole thing is 81.7, but I'm trying to figure out only what this part is. So I got to subtract off this little thing. So let's look at this part. I'm going to redraw that little side right there. We have this. We have this. We know this is 210. Right, because that's this part right there. I'm trying to figure out what this is right now, because that would get me this little part. And once I have that, I can subtract that from 81.7, and then I get the full bearing. So, well, if this is 210, this is a full circle. So 360 minus 210 gets me 150. And if that's 150, then these two are parallel, because again, they're both going north, so it makes this 30. So this little angle right here is 30 degrees, which is again, all that makes, if that's 30 degrees and this whole thing is 81.7, so it's a better 30 degrees. Right, so this corner is 30 degrees. This whole thing from here to here is 81.7. That makes this little corner. Let's draw that also so you can see that. Right, if I just extend this one, what I'm looking for, let's draw this. This angle's like this, right? Where this whole thing is 81.7. So I just figured out this is 81.7 minus 30. So it'll be 51.7. And we wanted to find out what from here all the way to here was, right? Because the bearing goes from 90 degrees, so from there all the way to there. So that'd be 360 minus 51.7, which kind of sucks, but I have a calculator. So 308.3. 3 fix it, 6 fix it, 308. But that's the bearing. So again, that part's a little complicated. I mean, not a little, it's pretty complicated. But the general idea is to find what bearing you need. It's a question from here all the way to here. What made it a little complicated was we didn't have all the information. We had to do law of sine to get this whole angle. And that's great, but that's not the bearing because the bearing has to go from north. So we still need to figure out this little angle is here. So we can figure out what this angle is. We just could do from there to 180. So all I did was, okay, law of sine to figure out this whole angle. Use this part to figure out what that is. That's what I did right here. I knew this was 210, so this had to be 150 because this makes a full circle. So that's 150. That makes this little corner right here 30 degrees because those two have to be 180. And then once you have that, I know the whole angle is 81, so subtract that from 30, you get 51.7. It's this little guy right there. And then the bearing is from the north, so it's all the way, it's everything except for that little guy. So it's 180 minus 360 minus 51.7, which gives us 308.3. Or 3 sig fix 308. And that's the lesson.